quiz, right? And I was just going through everyone's answers and seeing how well you all did. And I think some of y'all didn't answer that well. So I just want to like refresh and just check if you'll actually know the answers or not. So before that, a quick revision round of what happened. Can someone please tell me the 4 primary forces that act on a plane? Come on, first question of the day, guys.
Thrust, lift, drag, and weight.
And weight. Okay, great. All right, can someone tell me the primary control surfaces? 3 primary control surfaces. Who is going to answer this? Let me pick then. Muhammad Sanif, last time you didn't speak. Muhammad Sanif?
Yeah.
Yeah. Tell me the 3 primary control surfaces, please. Oh no. Okay. Tarun?
Yeah, actually, I wasn't there in the last class, in the last meeting.
All right. Yeah,
Okay.
correct. I did not see you, definitely. Yes, my bad. Sorry, Tarun. Partha, can you answer that? Aye.
Due to some network, I can't see the screen properly. Like,
Okay, fine. All right. Is anyone available to answer my simple
May I
question?
give a try?
Yeah, sure. Go ahead, sir. Sure.
The vertical stabilizers and the horizontal stabilizers and the ailerons.
Okay, now see. Uh, Vertical stabilizers and horizontal stabilizers are meant for stabilizing motion, right? But there are 3 surfaces which control the motion. Can you tell me which control the motion? Ailerons is correct. There are 2 more. One is for controlling the pitch, one is for controlling the yaw. So who wants to try at it? Karthike?
It's the elevator, rudder, and aileron.
Yes, thank you. All right, guys, I will just present screen and we will start off. Adityan, confirm if you can see my screen, please.
Yes, nice.
Yes.
Okay. All right, guys, before we just start off, I'll just show you this slide once and then we'll start off with our main content, okay? Yes. Okay, guys, can everyone see my screen? Can everyone see what is there on the screen?
Yes.
All right, great. Wait, I have to see your names also, correct? All right, before that, can someone please tell me what is the function of a vertical stabilizer? So I'm going to start picking out names then. Pranav, can you please tell me what is the function of a vertical stabilizer?
To provide the stability.
All right, great. What is the horizontal stabilizer?
To prevent the up and down motion of the plane.
Okay, I'll give that. Okay, fine. Can someone tell me the function of an aileron? Okay, let me pick out names then. Jayant Bansali, if you're here. Okay. Jayant? Buddy?
Yeah, hello.
Yes, much better, yes.
Am I audible? Yeah.
Yes, very, very, very.
So aileron is basically for turning the plane right or left.
Is it for turning or is it for rolling?
No, yeah.
All right, good. Siddharth A. Yes, Siddharth, are you here?
Yes.
All right. So that, can you please tell me what is the function of a rudder?
Rudder. What is that motion called?
No.
Roll? No. Okay. It's, okay. So rudder helps in yawing in the
Yes.
yaw motion.
Correct. Correct. Beautiful. Good. Good.
Took some time. But
Yes.
sorry.
Yes.
Sorry for that.
That's good. That's good. All right. That's Kevin. Oh, hi, Kevin. You here?
Yeah, I'm here. Yeah.
Yes. Kevin, can you please tell me the function? What is a fuselage and what is an aerofoil?
Uh, it's a long hollow tube like which
No, no.
holds
Tell
all the
me
pieces.
in the plane, what is the fuselage? What is the aerofoil?
Okay, fuselage is normally like used to determine the what. Just a second, wait. I guess I forgot about it.
You look at the figure. From the figure itself, everything will be there.
It's the it's a structural body, not intended to
Yes. Okay.
generate
So
lift.
fuselage is the body, correct?
Yeah.
Yes. And what is the aerofoil?
I'm sorry, I have no idea about that.
Okay. Okay. Kevin, remember last time I taught you two principles, right?
Yeah, correct. Yeah.
Yeah. Now tell me the first. What is the first principle?
The first one was the Bernoulli's principle.
Okay. Now where does Bernoulli's principle act in the plane? On which section of the plane?
I'm not sure. Yeah, I forgot.
Okay. No. Kevin, I'm going to help you out with this because you need to know this. Okay.
Yeah,
Kevin,
fine.
once
Yeah,
the plane moves forward, air is going to be passing around one particular object, correct?
yeah, correct.
Yes. And that object, when air passes above that surface, it'll go faster. When it goes below the surface, air will be slower. Now, which is that surface I'm talking about? Is it the body? Is it the tail? Is it the horizontal stabilizer? Or is it the wing?
It's the body.
Ay, ay. Okay, okay. No, Kevin, it's the wing. So aerofoil is the wing. I remember. I will just show you. Adityan,
Yes.
I think I see some new faces. So what do you think I should do? Try like repeat myself fast, or
We'll just go through the basics once. Basics. That.
yes? Okay, fine, fine. All right, guys. I will just rush through the basics. Very simple. Okay, so I'll just start off with Bernoulli's principle. Okay. Now, can everyone see my screen? Yes. All right. So for any motion of a plane, like everyone wants to know how a plane flies, right? And there are two basic principles. One is the equations of motion, that is the laws of motion by Newton, and you have Bernoulli's principle. Okay. So the laws of motion. The first law is that when a body is at rest, it remains in a state of rest. When the body is in motion, it remains in state of uniform motion until acted upon by a force. That is the first law. Second law is rate of change of momentum is directly proportional to the force applied. Third law states that every action has an equal and opposite reaction. Now, those are the primary laws, right? Now, for a plane to move also, the third law has to have a role in it because that is like the most important role. Every action will have an equal and opposite reaction. Okay. Then you have the main thing is the Bernoulli's principle. Bernoulli's principle states that for an incompressible fluid having a steady flow, the sum of the potential energy, kinetic energy, and pressure energy remain constant. Okay. Now I'm going to explain this using this particular structure, which is called the aerofoil. Okay. Aerofoil is a cross section of the wing. Always remember this. Aero comes from the word aerodynamics or aeronautical. That is the whole part of the Aero Club. So aero. Okay. So aerofoil is a cut section, a cross section of the wing. This is how it will look like. So what Bernoulli's principle states that now because of the curvature of this particular structure that you see, that is the wing or aerofoil, once air passes through it, like once air passes across it, due to the curvature, once the air moves above the surface, because of the curvature, the velocity of air on top of the surface is faster than the velocity of air on the bottom surface. Because of the difference in velocity, there is a pressure being generated on the below surface. This pressure is generated because Bernoulli's principle states that if my left hand side and my right hand side should be equal, correct? Now, in this equation that you see, okay, your left hand side is there, your right hand side is there. Now imagine you're applying the left hand side to the upper part of the surface and the right hand side to the lower surface, right? So we know that the pressure right now you're emitting the potential energy, okay? We're only going to see the center term, that is half rho v1 square and p1 p2, okay? So now in the first equation, we know that velocity is going to be higher, okay, and the lower surface velocity is lower. Now to make sure that this remains a constant, that means LHS is equal to RHS. Can someone please tell me what has to balance?
Pressure.
Yes, good. So there is a upward pressure which is going to act on the lower surface of the wing that will cause lift, okay? Lift as in the plane will move upwards. That is the basic theory for Bernoulli's principle. Kevin, can you tell me what is an aerofoil now? Kevin?
Yeah.
Yes, can you tell me what an aerofoil is now?
It's basically the shape, a solid body moving through a fluid processes and aerodynamic force.
Okay. If someone asks what an aerofoil is, say the wing, okay?
Yeah, fine.
Yes, done. All right. Now, apart from that, there are going to be okay, so these are basic terminologies of the wing. I need you all to remember this because in the today's session I'll be talking about it in detail, okay? So you have something called the airfoil, that is the cross section of the wing. Then you have a leading edge. So the leading edge of a wing is the front edge of the wing, okay? That is the curved part, that is the front edge, it's called leading edge. Then you have a trailing edge, that is the back part of the wing. Then you have a chord line. A chord line is a imaginary line which is horizontal, which is going to be connecting the leading edge to the trailing edge. Then you have the camber line, okay? A camber line is a line that joins the leading edge and to the trailing edge, but it is curved, okay? And this curvature of the camber line is what gives the wing its shape. So if it is a higher curve, it will be a more curved wing itself, okay? So this camber line will be equidistant from the upper surface to the lower surface. And camber, it is the asymmetry between the top and bottom curves that will come here, okay? So like I mentioned before, the front curvature part is called the leading edge, okay? So if this is the wing, this front part, the front part of the wing is called the leading edge, and you have the trailing edge at the back. Now this is the upper surface. This horizontal line you see, which is connecting the leading edge and trailing edge, this horizontal line here is called the chord line, okay? And that curved line I told you about is called the camber line. You should always remember that the distance from the camber to the upper surface and the camber to the lower surface will be the same, okay? So that will be the same throughout the wing. Now, this is going to be one sort of wing where the camber is curved, right? And this is going to be curved above the chord line, okay? When the camber and the chord line has the same curvature, that means both are straight, that means it is a symmetrical wing. If you see both, now in the first figure you see the upper surface is more curved than the lower surface. In the second figure, both are the same curvature up and down. And the last figure you see that the lower surface is more curved than the upper surface, okay? Carrying on, we have the basic 4 forces in flight, that is the lift, thrust, weight, and drag. So lift is upward acting force, weight is downwards acting. Thrust is the force that pushes your vehicle forward. It's similar to the engine of a car. The engine gives your vehicle power and moves the vehicle forward. Similarly, in planes, it is called thrust, okay, instead of throttle or whatever. And you have something called drag. Remember Newton's third law, every action has an equal and opposite reaction. So we have drag to counter thrust. Drag is basically like your resistance, okay, or friction or whatever. Yeah, so this is lift. I will just show you. This is weight vertically acting downwards. Thrust is going to push your plane forward. Drag is going to pull your plane back. It'll, try to stop the plane from going forward. Now these are the control surfaces. In an aircraft, there are three primary motions. That is the up and down motion along the horizontal axis, which is called the pitch movement. The left and right motion, which is along the y-axis, which is called the yaw movement, and the rolling action of the plane around the horizontal axis, which is called the rolling motion. Okay. Now fuselage is the body of a plane. We don't usually use the word body in terms of plane. We use the word fuselage. Okay. Then we have the tail section. The tail section is the last section of a plane, which comprises of two basic components. That is the horizontal stabilizer and vertical stabilizer. If these two components are not there in your plane, and if your plane just had wings and a body, it will not remain stable. It will not go in a straight path. It will not be horizontal parallel to the ground when it's flying. It will always keep rolling or keep moving randomly. So to prevent that, we need to have something that will keep it steady in a vertical plane and in a horizontal plane. So this is what I was talking about, the pitch motion, that is the up and down motion. Okay, so this is the nose of the plane, this is the tail. Okay, you see this up and down, that is called the pitch motion, which is controlled by the elevator. An elevator is a primary control surface which is located on the horizontal stabilizer. Next, we have the elevator, right? So in every plane, this is the tail section. Okay, this particular section is called the tail section, you see here, and this thing that is going upwards here or downwards here is called the elevator. This particular surface is responsible for controlling the up and down motion of the plane. Then you have another motion which is called the yaw motion. In your steering, like how you have a two-wheeler, when you have a two-wheeler, you use steering to turn left or right, correct? Now this left and right motion in planes is called the yaw. Okay, and this is how it will look like. Okay, and the yaw is going to be controlled by the surface called a rudder. Now I'm pretty sure that all of y'all have seen an aeroplane. Now you see the big long high tail is there, right? So the end part of the tail, okay, will actually move left and right, and that movement of left and right is going to be from a control surface called the rudder. And once this rudder moves in a particular direction, the plane will also turn towards that direction. Okay, so this is going to be called yaw motion. Then you have the coolest thing which you'll ever see. It's called ailerons, and this is the motion that will make the plane bank or roll towards the left and right. You see that? See, in the yaw motion, the plane is stationary, only the nose is going left or right. Okay, but the wings itself move and roll left and right. So this is the roll motion. Okay, now this is controlled by a control surface called as ailerons, and ailerons always come in pairs. Okay, so it has to be, if there's a left one, there has to be a right one, unlike rudder and elevators. Now ailerons always locate on the wings, either towards the tip of the wings or near the wing roots. Okay, usually in big commercial aircraft, it's located on the wing roots, whereas in other small aircraft, it is always located on the wing tips here. Okay, so this so ailerons usually work on the principle of a couple. Now everyone knows that a couple is a pair of equal, opposite, and parallel forces. Okay, so they're equal in magnitude, parallel to each other, and opposite in direction. Okay, so you see a left arrow here and a right arrow here. This is going to cause rotation. Okay, so this is what's going to happen when the left aileron moves up, like in this figure. Okay, so when the left aileron moves up, the motion will result in this left banking motion or rolling motion. Similarly, when the right aileron moves up, the motion of the plane will turn towards the right, the rolling motion. Okay, and this, all right. So I'm going to start off with today's topic. Did everyone understand what I've done so far? Like a quick revision?
Yes.
Yes. All right. Great. I think I see some new faces here. Smith Shah, are you here?
Yeah.
Yes. Did you understand what I just went through? I think
Yeah.
this is your first session, right?
Yeah, yeah.
All right. Do you remember the two principles?
The Bernoulli's principle
Yeah, and
and
Newton,
yeah,
Newton,
Newton's
laws of motion.
laws of motion. Okay.
Yes, great. Shah, like Smith. I mean, do I call you Smith or Shah?
Smith.
All right, Smith. You can, if you have any questions related, if you're not following, let me know. I will repeat whatever I have to say. Okay.
Yeah, sure.
Is there anyone else new? Jitin Kumar, are you? Is this your first session too? Jitin. Jitin, I am not a teacher. I am just your senior. You can definitely unmute and speak. All right. Silent audience. Diksha, any questions?
No, no questions. Thank you.
All right. And how is she sing?
Yeah.
Is this your first session here?
Yeah. Yes. First session.
All right. So are you following what I went through like so far?
Yeah. Yeah. I'm
All right.
following.
If you don't, if you have any questions, just either you interrupt me or you text in the group. Okay.
Sure.
Yes. All right. All right. For whoever's first session this is, my name is Sri Prasad. My friends call me Tinku, and I'm a core team member of the Aero Club, and I have 3 other people who I'm working with, and those three of them are from I think in second year, no?
Yes.
Yes.
Second year.
Okay. Yes. So the 3 of them are from second year, and they're very well experienced with whatever. So they're definitely qualified enough to teach you in further sessions. So Adityan is from EC, there's Akin from EC, and there's Rajat from mechanical, and I am from mechanical 4th year. The rest of them are from second year. Okay. And Adityan deals with drones, and Akin will be heading with quizzes, and Rajat's going to be helping out both of them, and I will be teaching you all about fixed wings. Okay. All right. Carrying on. So last session, I taught you all about the basic principles of flight, the motions involved in the flight, the control surfaces, that is the primary control surfaces. Okay. Now, usually all the small basic planes that you all build or travel in a small plane, they usually have those 3 basic primary surfaces. That is the aileron, the rudder, and the elevator. Now, for huge planes like your commercial planes or your fighter jets or whatever, they usually have little more stuff. Okay. And this is implemented only because of the application or their field or why they use it and everything. Okay. So continuing, we have the secondary flight controls. Now the primary flight controls are going to be the elevator, rudder, and aileron, and they will control the pitch, yaw, and banking motion. Okay. Now for secondary control systems, you have wing flaps, leading edge device that is called slats, spoilers, and trimming systems. Okay. So your first thing is going to be flaps. Now wing flaps. Okay. From the name itself, you should understand that this is going to be on the wings. Okay. And in the wings also, it will be placed on the trailing edge of the wing. Can someone please tell me where the trailing edge is? Harsha Ayappa, can you answer? What is the trailing edge?
End of the airfoil, right?
Yes, good. So the end edge, okay, the ending of the wing is called the trailing edge. Flaps are most common high lift devices. So now we know that the wing already generates lift, correct? Now in bigger planes, we want to increase the amount of lift while we're landing or when we're taking off. Okay, so flaps have 2 main functions. First function is to increase the lift. Second function is to increase the drag. Okay, so that is the basic function of these 2. I will show you what a flap looks like, but these are the different types of flaps. Okay, so first you have the plain flap. So it is meant, again, the flap function is universal. Okay, it is only meant for the increasing lift and to induce drag. Okay, this will come majorly into effect when you're landing. Okay, so it increases the airfoil chamber, results in the increasing coefficient of lift. Okay, now coefficient of lift will come immediately after this. Once I've dealt with it, I will teach you that in detail. Okay, but for now, understand that coefficient of lift means lift itself. Okay, then you have the slotted flap. It increases the lift coefficient significantly more than the plain or split flaps. Split flap is a deflected. So what happens? Okay, I will just explain it from this figure itself. Okay, now everyone can see my screen, right? So in the first top figure, that is here where my cursor is, okay, imagine this is your wing. Now in previously you just saw one straight figure which had like a pointy end towards the end, correct? Over here we have a pointy end but which can move over here. This particular section is called a flap. Okay, over here you see a split flap, which is the main branch, that is the main wing, and you have something extending from the wing downwards, that is also called a split flap. Then you have a fowler, very similar to design to this, but this entire thing comes out here. Okay, and then you have a slotted flap where there's a small slot kind of thing here. Okay, now we know from that figure itself that as the air passes across the aerofoil, the air above the surface will go at a faster rate and air below the surface will go at a slower rate. Because of which there's going to be an upward force generated on the lower surface, creating a lift for the plane, right? Now, this lift is going to be constant if you don't have flaps. What happens in a flap is when the air passes across the wing itself, right? Because there is more curvature being generated due to the flap deployment, there is going to be more faster air which passes across the upper surface of the wing, and the air on the lower surface will be relatively slower. Because of this greater speed on top, there will be greater pressure generated on the below surface. Hence, it causes more lift. That is the basic principle of how a flap works. Okay. Now, this is real-time examples where you will see, okay, whenever you travel in a commercial plane the next time, okay, if you're getting a window seat, just look outside. Okay, this flap movement you will see only during takeoff and landing. Okay, takeoff also only certain planes have it, but landing you will definitely see it. Now what happens is when you're landing, the plane is going to reduce speed, right? Now if it reduces speed too much, it has to touch the ground also safely. Now in case it has to pull up suddenly, if you're going at such a slow speed, it won't be able to pull up. So what the pilot does is he increases the curvature of the wing to generate more lift in case he has to go up suddenly. So to increase the amount of lift, that is what a flap is deployed for. So this is a figure of different types of flaps which is shown in commercial planes itself. All right, carrying on. Now like how you have flaps that is on the trailing edge. Can someone tell me when I mean slats? Okay, slats are going to be fixed on the leading edge. Can someone tell me what is the leading edge?
Frontal part of the wing.
Yes, good. So the front part of the wing is going to have something called as slats. Now slats are somewhat similar to flaps, but they are located on the front part, and this is also an extension to the wing. Okay, so slats also extend from the normal surface of the wing, and they are again meant for the same purpose. Okay, they are meant to increase the lift acting on the plane. So what happens is direct airflow to the upper wing surfaces and delay airflow separation at higher angle attacks. Okay, so this is for fixed flat. Again, for slats also, there are going to be four kinds. That is the fixed flat, the leading edge slat, that is, yeah, this is the same thing. Movable slats that consist of leading edge segments which move on track. Okay, so again, like I said, like how flaps also move, slats will also be able to move. Okay, so from here you see. Okay, so slat, also known as leading edge devices, are extensions to the front wing for lift augmentation. Okay, so please do not take the word augmentation any other way, please. So lift augmentation is going to be generating lift for your plane, right? Now flaps, like I said, is going to cause a curvature. Slats will also increase that curvature. So flaps only on the trailing edge, whereas slats is on the leading edge. Now if you see, this is the normal shape of the wing. Okay, now imagine if this particular curved part of the wing, this little extends a little forward. When this happens, obviously going to increase the curvature, right? And once the curvature increases, then definitely the air passing through also will get separated very easily and will be able to flow over the surface of the wing and lower and below the surface of the wing very smoothly. So that's why you see in this particular figure where my cursor is pointed. Where is my cursor? Yeah. Okay. The figure that I'm playing around with here. You can see in the leading edge there's something called slat here, and in the trailing edge something called a flap here. So because of this extension in the front part of the wing, that is the leading edge, it's going to cause a more curved wing, which will generate more lift. And due to the curvature also, because the curvature is going to be like that, it will separate the air layers. So now that you're going to, since your plane is moving forward, there's going to be air flow, right? And this air will get separated because of that curvature in such a way that the air will flow more smoother on top, and it will be relatively planar and slower flow on the lower surface. Moving on, we have something called spoilers. Okay, now in your cars and everything, and all these fast cars usually have that tail kind of fin kind of thing, which is called a spoiler. But the spoiler application there is different from the application here. Spoilers over there are used for a more aerodynamic performance and to create a downforce and to make sure that the car doesn't lift off during its motion. Okay, let me just ask someone a quick question which I asked last time. Smith.
Yeah.
Which branch are you from?
EC.
All right, Smith, if you have a really fast car and if it's going really fast, okay,
Yeah.
and if it doesn't have a, you know what a spoiler is, right, in a car? Yeah, and if it doesn't have a spoiler, can you tell me what will happen to the car?
The downforce will be less, so air can lift it up.
Yes,
at some
exactly,
point.
correct. So the spoiler is meant for that in a car, but in an aeroplane, okay, the spoilers are meant to disrupt the airflow. Okay, so what happens is very big planes, okay, now they have really good brakes, they have reverse thrust and everything, but the one thing that comes accompanied with a big plane is going to be the mass. So since big planes already have enough weight and then they're going to carry a lot of passengers, they're going to carry a lot of luggage, when the plane touches the ground, it's going to be a lot of effort to stop the plane. Can you tell me why it's going to be so hard to stop the plane? It's related to the second law of motion. I'm looking for one particular word. Can anyone answer?
Not sure.
Momentum.
Yes, good. I think Jayant answered that, right?
Yeah.
Yes. Okay. So because the momentum is going to be really high, now we know that momentum is mass into acceleration. Okay. The plane is already, once it touches the ground, obviously it's going to be moving really fast. So you're going to try and stop that movement. Now mass is not going to change because it's going to be constant. So to stop this movement, to reduce the amount of forces or just reduce the amount of acceleration, you have the brakes, you have reverse thrust. But to increase that also, you have something called a spoiler. Okay. So spoilers, what they do is on low drag aircraft. So these are usually meant for aircrafts which have less drag. Okay. I'm telling you, drag is the force that opposes the thrust. So it is the force that pulls your plane backwards. So sailplanes usually have this kind of thing. So sailplanes are planes that usually land on water and thing, if I'm not wrong, Aditya. Yes. So sailplanes are the planes that usually land on water. So spoilers are used to disrupt the airflow over the wing greatly to increase the amount of drag. Now remember, I told you that Bernoulli's principle mainly acts on the wing, and when this happens, it'll create lift, right? So if you disrupt that smooth airflow on the top surface of the wing, obviously it's going to disrupt the entire thing, and therefore Bernoulli's principle won't be able to act over there itself. So because of that disruption, because of the spoilers, it will stop the plane immediately. It's like if you're going in a train or if you're going in a car or something, if you put your hand such that your hand is parallel to the surface of the ground or the road or whatever, you see that your hand is able to like the air around your hand will go smoothly. But if you put your hand vertically, the air will get blocked, right? That is a similar fashion as to how spoilers work. Okay, so spoilers are already also called lift dumpers. So because once they disrupt the airflow, immediately there'll be a decrease in the altitude. Next, we have the elevator trim tab system. Okay, so the same system is also there for the rudder trim tab. I haven't added figures for the rudder trim tab, but I will explain to you. Okay, now we see in this figure, we see an elevator and we see a small surface here, right? Now, elevator trim balances the control force necessary to maintain aerodynamic downforce on the tail. Okay, this means that when a plane is flying, okay, take a commercial plane itself. When a commercial planes are flying, there's going to be some sort of turbulence experienced in different altitudes or whatever, and for different reasons. When that happens, your plane has to be stable, right? If the pilot just moves the elevator a little, you should know that even in a big plane, the elevator is actually quite big. And even for the tiniest elevator movement, there will be a great turn, right? So even if the pilot just moves and like about a centimeter or 2 centimeters of the elevator, because of the huge area, there will be a resulting motion in the plane. To prevent that kind of large motion, we have something called elevator trim tabs. Okay, so whenever a plane is like going, when a plane is going up and down, or because of random wind or whatever that acts in the plane, to maintain that level flight, only the small edge, like how you have the flap kind of structure, you have a trim tab. Okay, so there's a section of the elevator which will only move very little, and this will cause the aeroplane to remain steady flight. Okay, so it will make sure that the plane doesn't go up and down randomly. That's what a trim tab is used for. Even in even when you're modeling planes, okay, when that session actually happens, aero modeling, in that time also, what happens is we don't have a particular trim tab system, but before, like usually in normal planes, we see that the elevator will be perfectly horizontal and the rudder will be perfectly vertical with respect to the axis of the plane. But when you're modeling planes, we actually tilt that axis so it won't be perfectly vertical or horizontal, because we know that we have to counter that particular weight balance. Okay. Now we have a similar system for rudders. Now, like I told you, for elevator, it's up and down motion, right? Whereas for rudder, it's like usually all these planes and all, they usually carry their fuel in their wings and in the fuselage, right? So imagine if one particular, if you have, even if you're having two fuel tanks, if one of the fuel tank is empty and one of the fuel tank is like fuel is still there, there's going to be a balance. There's going to be like a disruption in the balance of the plane. So that's why they use a rudder to make sure the plane doesn't automatically turn towards the right if there is more fuel on the right tank. So again, the rudder, what happens is, to prevent that right motion, the trim tab turns towards the left, so that there is balance of that particular motion. Remember, when you're standing on a like a beam or a pillar, you use your hands, right? And if you're falling towards your right, you put your left hand, you keep your left hand stretched out, and you try and counter it with your left. Similar situation happens on the plane. Now, this is the thing I was talking about in detail, right? Yes. So this is the lift equation. Okay, so lift is going to be the coefficient of lift into the density of the airflow around it into the velocity square divided by 2 into the wing area. Now, remember I told you that aerofoils are cross-sectional segments of the wing, correct? Now, when we have to find out what is the coefficient of the lift, we have to find out what is the lift force and everything. So for finding out all of this, we have to simulate the structure. That is why you have something called as wind tunnel testing. Now, if anyone on this group ever has the opportunity to go and watch a wind tunnel test, please go for it. Okay, it's one of the most rarest things and one of the most coolest things. So what happens in wind tunnel testing is you see that this parameters as density, velocity, and wing area. Now these are the scientists that they already developed the wing, so they know the particular area. They already know area is already known. Now what they do is they simulate the amount of wind, okay, or the amount of air that is going through at some particular velocity. So that constant velocity is going to be maintained by the scientist itself, and the density of air also they'll know, and they'll keep it constant. So using these three itself, they'll find out the lift force, right? Now what happens is lift depends on the density of the air, the square of the velocity, and the air's viscosity and compressibility, okay, and the surface area of the wing, the shape of the body, and all that comes into picture, right? But the main thing is this equation, okay, the coefficient of lift. One way to deal with complex dependency is to characterize the dependence by a single variable. So whatever all these variables that you see highlighted is actually going to be replaced by one main thing called the coefficient of lift, okay. This allows us to collect the effects, simple and complex, into a single equation. So with one particular equation itself, they will determine the coefficient of lift force. Okay. So if the coefficient of lift is going to be higher, that means there's going to be more lift generated. That is the basic principle. Okay. So this is the basic equation of lift. Always remember it, because if you ever go for any interview with some for some aeronautical job or whatever, this is the first question they'll probably ask you, the basics, right? Now, I told you that you have four particular forces. So in planes, there are two particular ratios which are really important. One is called the lift to drag ratio. One is called the thrust to weight ratio. Now, the lift to drag ratio is the ratio between the lift force, that is the vertically upward acting force, and the drag force, that is the force which pulls your plane from going forward. Okay. So if a plane has a high lift over drag ratio, it produces large amount of lift for a small amount of drag. Now that means these kind of planes, what happens is these kind of planes have a greater curvature of the wing itself. Okay. So what happens is, because the more curvature, there's going to be more lift for sure. Now, if you don't have surfaces which will induce more drag, that means the plane is definitely going to have less drag. So the lift to weight ratio, lift to drag ratio will be high. When that is high, the plane will generate more lift. Okay. And thrust, again, I told you thrust is being produced by burning of fuel or whatever. So to generate high thrust, large quantity of fuel is burnt. Low thrust aircraft requires low fuel usage, right? So what this means is, if a plane has to gather that drag, a lift, right, it has to have more velocity, like the velocity of air flowing over the wing should be higher. And that won't be possible if the curvature is not enough. So if there is more curvature, even if it's going at a relatively low speed, the amount of air flowing over the wing will be faster. Hence, there will be more pressure build up at the bottom, pushing the plane upwards. So it depends for what purpose you want. If you want a plane that will not go at high speeds, but it will remain in the air for a long time and stuff, that's when you use a higher lift to drag ratio. So usually gliders, okay? Gliders are planes which don't usually run on a motor or engine. Okay, they just take off from a high altitude and they just glide the plane. So it's gliding is basically called controlled flying. Okay, controlled falling, sorry. So for gliders and everything, they use a high lift to drag ratio. So this is what I mean. Now, how you have a lift coefficient, you have the same formula, but you will only replace the coefficient of lift by coefficient of drag. So when you cancel the rest of the terms, you'll have coefficient of lift to coefficient of drag. That's what you get by your lift to drag ratio. Okay. So this is the lift, this is the drag. So the ratio is lift over drag. So high L over D is high efficiency. That means it will be for long range. Whereas, high L over D will also be used for large payloads. Now, payloads means Okay. So payload does not only mean like missiles or whatever. Payloads also mean like your cargo, your fuel tankers, your commercial planes, because they're carrying so much load in them. That's why they're called large payloads, right? So usually planes like that, they need a high lift to drag ratio, because if the lift is going, you don't need fast, you don't need to burn a lot of fuel to produce so much speed over the airflow, over the aerofoil. So even at lesser speeds, since there is more airflow on top, you will get a better lift. Okay. Then you have something called a thrust to weight ratio. This is the second ratio. Thrust to weight ratio. Thrust is the force that pushes your plane forward. Weight is the ratio. Weight is the force that brings your plane vertically downwards. Okay. So a thrust to weight ratio is a ratio between thrust and weight. Now, for a thrust to weight ratio, if the thrust to weight ratio is more than 1, that means the plane is definitely going to go shooting really fast. Okay, so usually most of your fighter jets will definitely have a higher thrust to weight ratio. Okay, so an aircraft with a higher thrust to weight ratio has a higher acceleration. For most flight conditions, an aircraft with a higher thrust weight ratio will have a high value of excess thrust. High excess thrust results in high rate of climb. Now, when the thrust to weight ratio is really high, usually the wing is not that large, or the surface area of the wing is not that much to produce enough lift. So what they do is they push in, they burn more fuel, they consume more fuel, and because of the excess fuel consumption, there's going to be excess speeds. Now, due to this excess speed, the lift also will be able to be controlled, and there'll be generation of lift even for a small wing area. That is why you use thrust to weight ratio. And thrust to weight ratio is definitely used mostly for planes which require a high climb rate, or for different applications such as dog fights, or going into the atmosphere or something, or going out of space. You need to have a high thrust to weight ratio. Okay. So again, this is a figure which represents that. So since the mass will get cancelled, okay. So because force is thrust, rate of change of momentum, right? So you have force is mass into acceleration. Mass will be cancelled here, and weight is mass into gravity. Mass will be cancelled here. So you have only acceleration to gravity. That is basic thrust to weight ratio. Then you have something called the angle of attack. Okay. Now this is a very, very important concept in terms of aeroplanes, especially fixed wings. Okay. Now I told you that the aerofoil is shaped in such a way that it splits the amount of airflow on the upper surface and the lower surface of wing, so that the upper surface has a faster rate of airflow. Okay. But the splitting can happen only within a range, okay, of angular orientation. So the angle of attack is the angle that the wing. Oh my god. Okay, guys. See, I mean, the session was supposed to be till 3:30, right? So does anyone have any issue if it goes on?
No issue. Carry on.
Anyone else?
No, no issues.
All right. Aditya, if there's anything, we'll deal with it. Okay.
Fine.
Okay. So you have something called the angle of attack. Now see the first figure. The angle of attack is the angle that the wing makes with respect to the oncoming air. So the angle between the chord line or the leading edge with respect to the oncoming air is called the angle of attack. Okay. So what this means is when your plane randomly lifts off, right, that the oncoming air is going to split into two layers, that is above the surface and below the below surface of the aerofoil. This splitting thing will happen only if the angle is almost parallel to the airflow or little angular orientation as of here. Now this is the chord line of the wing. Okay. Now you see that over here also this is the chord line from here to here. What happens is if the airflow is going towards that direction of the wing and the angle is too much, then the amount of air that flows above the surface of the wing will not stick to the wing surface. Okay. Now, the whole principle of Bernoulli's will only occur when there is laminar flow. Okay, that is, the flow is in terms of layers, and these layers are going smoothly over the upper surface. When the layers are not smooth enough, there will not be any lift generated. Okay, and when there is not lift generated, the plane will come crashing down. Okay, what happens is your lift to angle of attack graph is very similar to your Hooke's law. Okay, Hooke's law states that with the increase in strain, there's going to be stress strain curve, right? Yeah. With the increase in stress, there's going to be a increase in strain till one particular point called the fracture point or proportionality limit, after which the what do you say, the object or the whatever thing that is there is going to break. That means it will not be what do you say, proportional anymore. So the same thing with this. So the angle, if the angle of attack increases, even the lift will increase. But once the angle reaches some particular point here where my cursor is, okay, that particular point is going to be called the critical angle of attack. Okay, now if the angle of attack increases across or over the angle, critical angle of attack, that means the plane is going to stall. So what happens in a stall is the airflow on the above surface will not be smooth and it won't be laminar. Because of the disruption, there'll be a lot of disturbance in the airflow here. Okay, lift will not be generated, and your plane will automatically your plane will automatically just fall backwards, like how over here the wing is particular in this angle, right? This angle increases, it will just fall backwards, or the plane will just try to, because of there's going to be so much what do you say, okay, I'll explain like this. Okay, remember that hand incident I told you? If you put your hand outside a moving car or a train, and if you turn your hand vertically or in such a way that it's perpendicular to the direction of the wind, there's going to be a lot of airflow obstruction, right? So when that obstruction happens, what happens? Your plane also will go back. It'll just continue going back itself, right? And only if you put force and bring your plane back to such an angle where it passes through the air smoothly, only then will the plane continue to, you can get control of your plane. So similarly, to counter a stall, the only way you can counter a stall is if you somehow try to manage and align the plane's wings such that it is parallel to the surface or parallel to the oncoming air. Only when it is parallel to the oncoming air can you recover from stalls. So when a plane actually stalls, the plane will come crashing down. It will just come crashing down, and that is majority of the crashes which you see wherever on the news or whatever. It will be because of some idiot trying to show off in his small plane, and he won't know how high to go or whatever, and then it will be a stall. Okay, stall also happens when you don't go at a quick when there is not enough speed. Now I told you speed is required for lift for creating lift. Okay, if there is not enough speed also, there is going to be a stall. Okay, because there won't be enough lift, and therefore the air won't get separated into that smooth and that smoother, faster air on top and smoother, slower air on down. Okay, now all right, so now you know that you have seen so many types of wings and there's so many different configurations of wings. Okay, so this is the last section. I will talk about the different types of wings and then we can wind up. Okay, so the different types of wings, we have the low wing, that is here. Okay, so you have the main fuselage, that is the body, and the wing is located below or bottom of the fuselage. Then you have the mid wing. Okay, that is exactly the middle of the fuselage. Then you have the shoulder wing, that is right little above the body of the fuselage. And you have the high wing, which is on top of the fuselage. Then you have the parasol wing, which is placed at a height from the top. Okay, so you have this particular configurations. Again, I'm telling you, all these configurations have different applications and have different pros and cons. Okay, if one was better than the other, then all the planes would definitely have the same shape of wings. Because not all the planes have the same shape of wings, we should understand that some of them have their own pros, some of them have their own cons. Then we have something called the dihedral and anhedral wings. Okay, a dihedral is when the angle, there's an angle. So usually wings are, okay, see in the above figure, all these figures you see that the wings are completely horizontal, right? But over here you can clearly see that there's an angle, okay, like a V kind of thing formed for the first thing, that is called the dihedral. Then you have like a upside down V, that is called an anhedral. Okay, so dihedral tips are higher than the roots. So the tips meaning this is the tip, okay, and the root is where the wings are joined to the body. Okay, so dihedral is when the tips are higher than the roots, and anhedral is when the tips are lower than the roots. Okay, and they both have their own particular function, which I will not be talking about in detail here. Okay, apart from this basic things, you have about 7 or 9 different other shapes. Okay, so I will show you this. This is really nice. Okay, so the first one is rectangular wing. Rectangular wing is the simplest to manufacture. It is non-tapered, straight wing that is mostly used in small aircraft. This wing extends out from the aircraft's fuselage. Okay, so now you see over here how the shape of the wing is. Now just imagine a rectangle. Okay, that is exactly how the wing is going to be. Elliptical wing is for aerodynamic purposes because it is more efficient because of the aerodynamics. Okay, because elliptical span wise, so that means the left wing and the right wing will look somewhat like an ellipse. Okay, an elliptical object. So this really helps. What it does is it really helps in the lift distribution of the plane, but the maneuverability will get little affected. Okay, and an example of this plane is an old fighter kind of plane, which is called the Spitfire. Okay, so mostly all these kind of planes were used in our First World War and Second World War, and the Spitfire and this P-51 Mustang, they're brilliant planes. Okay, if you ever get a chance to see some videos, and please go through the videos. Then you have a tapered wing. So this particular wing, from the roots to the tip, it begins to taper. Okay, and the chord of the wing, it varies. So chord, I told you, was the distance between the leading edge and trailing edge. So from the root it will be the maximum, at the tip it will be the minimum. Okay, so that is an example of a P-51 Mustang, and these are your pictures. Okay, this is the first wing which I told you about. This is the rectangular wing. You see there is no other shape. It's just completely straight here, and rectangle. This figure you see is the elliptical wing. You see that ellipse. This particular figure, okay, over here the lift is really good, but the maneuverability is going to be quite bad, because once it turns, there's going to be a lot of obstruction to the airflow because of the large surface area and everything. And over here you see this is a P-51 Mustang. This is the Spitfire. Okay, so if you see over here, the wing is actually tapered. So the maximum width is over here and the minimum width is over here. So that is tapered. Okay, then we have the delta wing. Okay, can someone please tell me an example of the delta wing? I'm sure you've heard of it. Which Indian fighter jet has a delta wing? There are actually 3 current planes actually. So you can tell me one at least. Anyone? Let me pick out names. Jitin, are you here? Okay, Jayant, you can answer this, right?
No, I have no idea.
Okay, Harsha?
I don't know.
Okay, one airplane is right on the screen only. Like you can definitely just see it and answer. Pranav, do you know the answer for this?
F-15.
I said Indian Air Force. There are 3 jets. Okay, I'll tell you. A delta wing is like a triangular wing. Okay, when you see it, it is not like a commercial wing at all. Okay, the main advantage of a delta wing is that it is efficient in all for supersonic, transonic, and subsonic. Okay, so can you tell me an example of this? I'm telling you, it looks like a triangle.
Tejas.
Who said that?
Parthasarathi.
Yes, good. Tejas is one, definitely correct. There are 2 more planes. In that 2, one is already mentioned over here. Come on, guys. I thought that y'all were aero enthusiasts. This is your Indian Air Force. Come on.
Mirage is the second one.
Yes. Mirage. All right. Sorry. There are actually 4. Okay, there are actually 4 planes. So first one is your Mirage 2000. Okay, and if you already know, this is the same plane that was used for the Balakot airstrikes, right? Remember, the Air Force conducted like a deep penetration bombing strike in Pakistan. This was the plane used. Okay, Mirage 2000. Then you have the Tejas, like how Partha said. Then you have the MiG-21s. Okay, MiG-21s also you have. And finally, the most recent plane. Can someone tell me the most recent Indian Air Force plane?
Rafael.
Yes, Rafale is also a delta wing. Okay, so
Excuse me. Even Sukhoi has a delta wing, no?
Sukhoi doesn't have a delta wing.
But the shape is similar, I
Yeah,
guess.
that's a
But
twin
it is
fin wing.
not a delta wing. Adityan, do you
Okay.
want to answer his question?
I couldn't hear his question.
He said that even the Sukhoi has a delta wing, right?
No, the Sukhoi is not a delta wing.
I will show you the wing, Jan. Just give me a minute. Okay.
Yeah, sure.
So the delta wing is a triangular wing, I told you, and it is meant for supersonic, subsonic, transonic. Okay. Now, the main disadvantages of this particular aerofoil is the low aspect ratio. Delta wings always increase the drag. Okay, so whichever plane that usually has a delta wing, they use really powerful engines to create, to get rid of that induced drag. Okay, then at low speeds during landing and takeoff, these wings have a high angle of attack, mainly because at such low speeds vortices generate the lift. So what happens is, when these planes usually land, right, usually all these planes will come at a particular angle, right? So high stall angles of the delta wing compensate for this. So this particular plane doesn't have to be almost parallel to the ground like commercial planes. Okay, this can come at a particular angle also because it has a high angle of attack. I'm not sure if you've seen it, but there's a maneuver. Okay, if you see during airshow or whatever, usually the Sukhoi and the Tejas do. It's called a slow fly past. Okay, so what happens is the plane will almost be at an angle of 45 degrees, and it will go very slowly. Okay, and it's a beautiful maneuver because when it happens, right, like there's so much sound that like you can hear, and your heart, you can feel the vibrations in your entire body. Okay, that's really crazy if you actually observe it in person. So that's really good, and this happens if you see the angle at the angle of the plane for a Tejas and for a Sukhoi. You will see the difference. Okay, in Sukhoi is going to be much more compared to the Tejas. Then you have something called a trapezoidal wing. Now the wing, like the name suggests itself, it's going to look in the form of a trapezoid. Okay, and this kind of wing is definitely mostly used for stealth. Okay, because how a plane get detected is because the amount of radiation it reflects back to the the radar or whatever. Okay, so what happens is, in this particular design of the wing, there's going to be less reflection kind of thing due to whatever components they add on the surface of the wing. But because of the almost flat like structure and the trapezoidal wing, it's going to have effects on the stealth. Now tell me, okay, there are 3 planes, 2 of which are delta wing. Can someone please tell me the names of these planes, if it is possible? I will help you out. I will give you the starting letter if you want. Anyone want to take guesses? Siddharth?
The type of wing, right?
No, you tell me the name of the plane.
No idea. I think it's Lockheed Martin F. I'm not sure. Sorry.
No, you got it. You definitely got it. It is definitely an F, but what version? I'll give you 2. Okay, there is an F-35 and F-22. So my cursor is here right now. So tell me, which plane is this? Is it the F-22 or F-35?
F-22.
Yes, correct. This is the F-22 Raptor. Okay, I will give you a short intro about this. All right, the left plane that you see here is actually a delta wing. Remember, this is a triangular wing. Now, can you tell me, in a delta wing over here and here, can you notice that there are no horizontal stabilizers? And over here also, it's like these two things are actually the elevator. This is the tail, rudder, and everything. But over here, if you see in delta wing, there is no horizontal stabilizer at all. This is because the wing itself acts like a stabilizing thing. Okay, so it'll give the stability to the plane, and to allow the, and there's no elevator also is actually located on the trailing edge of this wing itself. So when that moves up and down, the plane also moves up and down. So that's a crazy advantage of a delta wing. Now this, the right side you see is a Mirage 2000. That particular pipe kind of thing is for mid-air refueling, and this is a Eurofighter Typhoon, one of the craziest fighter jets. But you see down is the King, okay, the scariest fighter jet you could say in the West for America. Okay, can you tell me what class of plane that belongs to? This F-22 Raptor. Is it a 4th gen, 5th gen, 6th gen? Anyone? Jayant, would you like to have a try?
I think it's the latest one, the 6th gen.
All right, actually that's gonna be wrong. That is actually a 5th generation fighter. Okay, so there are only 3 such planes in the world, the 5th generation fighters, out of which 2 of them are American and 1 is Russian. Okay, and 5th gen is actually meant for stealth. Okay, so whenever you hear the word stealth, there should be only these 3 planes coming. One is the F-22 Raptor. US will not sell it to anyone else. This is exclusively meant only for them. They have a second fighter which is called the F-35, that they're giving it for people. Okay, and the deal was actually India also was supposed to buy F-35s, but because it was too expensive and everything, they did not. F-35 will look somewhat similar to this, but it will be smaller and it will have only one engine, okay, or one turbine there. And finally, we have this Russian plane counterpart. Okay, the Russian counterpart is called the Sukhoi 57, Su 57. Okay, and I will, like, if you all are on Instagram, I will definitely send you all videos. One second. Oh yes, I am so sorry. Apart from these 3, you have the Chinese one. I really do not like the Chinese plane, so I keep forgetting about it. This is called the Chengdu J-20. Okay, so the J-20 is also another stealth fighter, a 5th generation plane. So you have 4 basic planes: F-22, F-35, Sukhoi 57, and J-20. Then you have the ogive wing and swept back wings. Okay, so the ogive wing design is used only for very high speed aircrafts. So the complex mathematical shape of this aircraft is derived to minimize drags. Okay, so whenever you're going really, like, okay, if you're going really fast, there's obviously going to be a lot of drag, because third law of motion, when there's an action, is going to be an equal and opposite reaction. So if the thrust is more, there's obviously going to be more drag. So to decrease this drag, they have designed this particular wing called the ogive wing. Okay, so the ogive wings, they reduce the amount of drags when the plane is going at supersonic speeds. But the main disadvantage of these types of wings are they are very complex, and the manufacturing them is very difficult. Okay, and when they move at speeds which is less than the speed of sound, it doesn't actually perform that well. Okay, and the example for this type of wing is the Concorde. Okay, then we have a swept back wing. This is the most common kind of wing that you see. So this is when the leading edge are swept back, like all your commercial planes will have a swept back wing. Okay, I will show you that also. So yeah, so answering a question, who was that? Jayant, I think it was you, I'm not sure. Was it you?
I had asked about the Sukhoi.
Sukhoi, yeah, correct. So the Sukhoi also will have a swept back wing itself. Okay, so the wing will look back, like the leading edge will actually go towards the back, like bend kind of towards the back. That is the same thing you see in the Sukhoi also. Now, the left plane is a very legendary plane. Does anyone have any information about it?
Concorde.
Yeah, okay, yes, everyone knows the name. Adarsh, can you please tell me some explanation?
I don't know much about it, but I know that it was started as a. I mean, they wanted to introduce into transportation, but they couldn't.
Okay, so actually, the Concorde is the only commercial plane which goes at supersonic speeds. Okay, and they had to ban this plane because when it took off or when it landed, right, it would make so much, it would cause so much vibration that building windows would definitely shatter.
Yes, and many people actually claimed the complaint about it, so they had to stop.
Yes, exactly. Because the loud noise or whatever, but this plane was the beast. Okay, it would, it would travel like if a normal commercial plane would take 5 hours for a journey, this would take at least 2.5 to 3 hours max. That's how fast this plane was. Okay, it's incredibly fast, and this was operated by British, I think. Correct? Are there British?
British and the French Airways, and
Air
they shot
France.
it because of loss
British
of
and
speed.
French, yeah.
Yes. See, great. There was also one other plane which is also supersonic. That is the Russian plane. It's called Tupolev Tu-144. Okay, that is also very similar to the Concorde, but Concorde has more fame, definitely. Then this is the last type of wings. So we have the forward swept wings and the variable swept wings. Now remember, I told you swept back wings where the leading edge goes backwards, right? Now imagine the leading edge are like swept forward, they're literally pointing towards the front. Okay. Now these kind of planes are actually very rare these days, and I don't think most planes are actually using this, but they have certain exceptions. So one main disadvantage of this type of configuration is that because of the flow characteristics. Now I told you, right, the leading edge is going to be curved and the air has to flow across them smoothly for it to generate lift. So if the curve is going to be forward direction, it's going to be very hard to generate the lift. So the main issue with this type of plane configuration is that when the plane was in operation, because of the design of the plane itself, there would be a lot of twisting motion of the wings because of the load that it's facing, right? And there'll be greater stress on the wing root. That is the junction at which the wings are joined to the fuselage. There's going to be a lot of stress over there. Then it'll cause failure. So they didn't really recommend it. Then you have the variable spec wings. Okay, so these planes are actually. Has anyone seen the movie called Top Gun over here? Okay.
Yeah.
Yes. So if anyone is actually interested in Air Force and everything, Top Gun is like the movie, okay, like the craziest movie ever. And in Top Gun, the plane that they use is called and it's called the F-14 Tomcat. Okay. So what happens in that wing is the wings actually change the direction, their orientation based on the speeds. So initially, in taking off and all, it'll be like horizontal. Once it goes really fast, the wings actually close in to form like a delta shape. I will show you that in the next picture. First is the left figure, which is called the Su-47. Okay, the Su-47 has a front swept wing. Remember, all other wings are backwards, right? This is actually bent towards the front, and it offers high speed that is there, but with high speed comes great risk. Like at the junction where the wings are actually fixed to the fuselage, there's going to be a lot of stress there. Hence, the wings will probably just break off and going really high speeds, and it's very hard to control. And that's why they didn't really recommend the continuation of this project. Okay, over here, this is the F4. This is not the F-14 Tomcat, but a similar plane. So over here, you see the wings are actually swept back. Okay, but you see the angle here, here, and here. Can you see this is all actually the same plane at different speeds? When the plane is going at high speeds, the wing changes into that particular formation. Okay, making it more agile, more aerodynamic, and it will be hitting faster speeds. Over here, since it's going relatively less speed, the amount of drag also won't matter that much. But when the wing is pointed to that extent, the drag will be reduced, exponentially, and hence we can reach faster speeds. So that is the basic principles of types of wings and everything. And that comes to the end of my presentation. So guys, if any doubts, y'all can please ask now. I think the turnout today was less. I think probably because everyone just got done with college. But did everyone understand today's session at least? Y'all can unmute and speak, guys.
I have a doubt. It might be a little silly. So you were talking about flaps, right?
Yeah.
So in that discussion, you just told that we use flaps to increase the lift during takeoff and landing, right?
Yeah.
So I want to know how that lift will actually help in a proper landing? Uh, how like if it produces lift, then how is it useful in landing?
All right. I'll tell you. Okay. Now, when an airplane is coming for landing, right? First of all, the airplane landing speed and not. I think, do you know the landing speed or touchdown speed? Do you know? Do you know that?
Sorry, what?
The landing speed or touchdown speed
Of?
of
No, I
a
don't know actually.
commercial plane.
It's quite high. That's
Yeah.
all I know.
All right. All right. Anyway, coming to your question. So what happens is, first of all, the plane is going to be coming at a fast speed, right? But it's not going to be fast enough when compared to landing, when compared to takeoff. So what happens is, when the plane is going to be coming at that particular speed, it has to make a smooth landing so that it doesn't, screw up the plane's structure itself. Okay. So when the plane is going to come, it's going to come at a particular angle. So that is, the nose is always up when it touches the ground, so that the rear landing gear touches down first, because that will take most of the load and everything. So when that happens, okay, because of the first thing is the angle of attack will be varied, and second thing is because of the speed. Now, since you're actually going to be at a little relatively slower speed and higher angle of attack will be more, so when you have to pull up also, you can't just randomly increase the speed. Like the throttle, if you just put the throttle at full that particular moment, the plane is not going to go fast immediately. Okay, only if the plane is like relatively parallel according to the oncoming wind, only then will the plane push forward faster. When that happens, only then will the plane be able to randomly, like if it has to pull up suddenly, it can pull up. So when you're landing, if the flaps are not deployed, or if the flaps are deployed, it's going to create more lift. So the speed at which the plane comes itself, first thing will get reduced that time, because there's going to be more lift there. Okay. And because of the speed that they're coming in for landing is going to be a little low, the amount of air that flows over your wing also will be relatively low, the speed of the air. So when you have to generate lift at that particular moment, it's going to be quite hard. So if you want a smooth landing, you need to create an environment where there's, even if little movements of the elevator are there, it will cause a little lift, more lift. That's why you use the flaps to get a smoother landing. Is that clear?
Okay. Yeah. Thank you.
You're welcome. Any other questions, guys? Asha, Ayappa.
No questions.
Okay. Satish Reddy. All right. Karthikeya, do you have any questions?
No questions.
Okay. Siddharth A, do you have any questions?
No, nothing from my side. Well explained.
Mridul Sadashiv.
Yeah, I have a question. When you told about that the engine part, that we are using two engines in a plane, so to counterbalance the disbalance caused by using only one engine, so we use the rudder to stabilize that. So
One
why
second.
not to
Which part was
why
that?
not
Which part was that?
means it was the part where you told about when we use two fuel tanks, two
Fuel
fuel
tank.
tanks.
Yeah, fine. Trim control. Yeah.
Yeah, yeah.
Hmm.
So there, if we use only one fuel tank, so there will be a disbalance caused in the plane. So to counterbalance that, we just stabilize it using the rudder. So
Yeah.
why not use both the fuel tanks at the same time?
No, so what? So what usually happens is, fuel tanks are used to the same amount and from both tanks. So when the fuel is being consumed, it is like the fuel from both tanks will reduce for sure. Okay. What the slide actually says is, when there is more fuel in one tank than the other. Okay, this happens sometimes because of the fault in either during the flight itself, there is more consumption from one side and there's some blockage or something, hence fuel is not getting absorbed, used, consumed from that particular tank. Or when they're filling the tanks itself, they don't fill it equally. Okay, so when this happens, then there'll be that imbalance, right? So to counter that imbalance, that time they'll use the rudder trimmer.
And plus, when on ground, pilots usually use only one engine. They don't turn on both. They don't use both fully.
Yeah. Anything else, Dashiv? Kevin, do you have any doubts?
No doubts.
All right, so you understood today's session for sure?
Yeah, I've understood.
Kevin, did you do the quiz last time?
No, I couldn't attend the quiz. No, I didn't.
All right. I want you to do that quiz, okay?
Yeah, fine. Yeah.
Jayan, did you have any doubts?
No, no doubts.
All right. Adarsha, do you have any doubts?
No doubts.
Okay. Then I think we're done, guys. We will have, I think, another quiz session tomorrow, which will share, what do you say, a document like a G form or whatever, and then we can continue. And guys, from the next week, right? Next week, I think we will continue with our drone session. So drones will not be taken. Drones will be taken by Adityan. Okay, and drones are a little more, like you can relate to them more because y'all can easily manufacture. You can easily make a drone also. Okay, compared to an like a fixed wing, drones will be much easier build. So make sure you'll attend and tell your friends also, because y'all can attend it, and we will definitely have a lot of workshops once college is offline for drone building. Okay, so yeah, please come next week for this. All right, guys. So y'all can leave if y'all want.
Thank you, ma'am. Well explained.
Thank you.
Yes, sir.
Thank you.
Thank you.
Thank you, guys.
Thank you.
Thank you for joining.
Thank you for joining, guys. Hello, hello. Satish Reddy is also left. Hi, Partha. Partha also left. All right, guys. How's today's session?
It's good, man.
It
It's
was
good.
good. Great, man. Great.
Please avoid the calls. No, I can stop recording. Show stop.
Yeah.
Oh, wow.